This is Chapter 7, number 12. In this scenario, companies are interested in the demographics of people who listen to the radio programs that they sponsor. So a radio station has determined that only 20% of listeners phoning in to talk to a morning talk program are male. And the station manager wonders if adding a male host to the program would actually increase the proportion of callers who were male. After adding the male host, the station records the gender of 200 people who call into the program during a week. The station is willing to view these 200 callers as a simple random sample of the population of all those who call into this program. So for the moment, assume that the addition of the male host has no effect on the proportion of callers who are male. If p hat is the proportion of callers in the sample who are male, what are the mean and standard deviation of the sampling distribution of p hat? Well, the mean of p hat should always equal our population proportion p, so that would be 0.2. But our standard deviation of p hat is going to equal p times 1 minus p divided by n, and we take the square root of that. So that's 0.2 times 0.8 divided by our sample size of 200. We take the square root of that and we get 0.028. What assumptions are you making when we use this formula for the standard deviation of p? So in order to use the formula for standard deviation of p hat, we need to know that my sample size n is less than 10% of the population. So we're assuming that 200 is less than 10% of the population, or in other words, that at least 2,000 people listen to this radio talk show, or whatever it is, to this radio station. Alright, so now let's go to part C. Part C tells us that in fact during this particular week 50 out of the 200 callers were male. Does this provide enough evidence to suggest that the proportion of male callers has in fact increased? Well, let's again take a look at a picture here. My sample size was 200. We're working with proportions. We have at least 10 successes and 10 failures. So my large counts condition has been met for proportions. So we can assume that the sampling distribution is approximately normal. The mean of the sampling deviation would be 0.2. The standard deviation of my sampling distribution from above is 0.028. Now in this particular case, if 50 out of the 200 actual callers were male, that means that p hat was 50 divided by 200, which is 0.25. So 0.2 plus 0.028 is 0.22, so 0.228, excuse me, so 0.25 is going to be pretty far up there on my curve, so I'll put it about right there, so 0.25. So we want to know, well, what's the probability that I would get a value of 0.25 or larger if in fact the true proportion of listeners was still 0.2. So we're going to calculate the probability that we would get a p hat of greater than 0.25 is going to be equal to the probability that I get a z-score greater than or equal to 0.25 minus 0.2 divided by 0.028, and that is the probability that z is greater than 1.79, and that is about 0.0367. But now we have to interpret this. This means that there's only a 3% chance I would get the sample that I did if in fact only 20% of the listeners were male. That's not very likely to happen, so it appears that there is sufficient evidence to conclude that the proportion of male listeners has in fact changed.